This is really our last presentation for DecisionCAMP, and it's really early, probably 4 a.m. for Russell right now, so we appreciate your patience. And based on my few conversations with Russell, I understand that he has many years of experience as IT professional, and he developed mainly in healthcare industry, and he developed a lot of healthcare applications, such as clinical costing, auto coding, and what I also know that Russell hates languages like Java with strong typing, and he really likes Python, and he says this is the best language for development, but Python is missing DMN. And when he discovered DMN, he decided there are several rule engines in DMN in Python, but he decided to implement DMN. So this is probably a few years efforts, or maybe less, but it would be very interesting to hear his experience. And Russell, please take over. Tell us.
Okay. So I'll start with an apology because I have far too many slides. So if you see things flashing before your eyes, just download the deck at the end. So the question is Python a good fit for DMN? And the academic approach here would be to simply, oh, good boy, would be simply to look at what's similar between the two, right? Now, you're not really comparing DMN, you're comparing FEEL, the expression language that's defined inside DMN, and you're looking for similarities, because the more similar the two things are, the easier it should be to implement some DMN capability in Python. And similarly, it should be relatively easy then for Python users to leverage any developed DMN capability. So we're looking for similarities. There are lots of them. The big one is the fact that they're both loosely typed expressions. Now, what does that mean? Well, here's a little bit of DMN, and you can build a rules engine that does this, and it'll do exactly what you think it's going to do. It'll add B to C, and then when it's and give you the answer A, and it'll do that regardless of what B and C are. If you make B and C a couple of strings, you'll get back A, and it'll be a string, the concatenation of B and C. If you make B a date and C a duration of 1 day, you'll still get back A, but this time it'll be a date, and it'll be the day after B. And FEEL even tells you what's going to happen if you really muck this up and try and add two things that don't add, like a string and a number. You'll get back A, but it'll be null, because DMN never fails. It just gives you funny answers. Now, Python is also loosely typed, and it also has a sort of suck it and see paradigm for programming that makes implementation of this trivial. There's the Python, 2 lines of code wrapped in a structure called a try and except. What Python will do is it'll add B and C, and if that works, then A will adopt that value, and if necessary, change its data type to accommodate that answer. On the other hand, if it fails and you get an error code and a stack trace and your thing's about to die, Python will silently sweep that under the rug, pretend it never ever happened, make A none, and continue as though that was the intended outcome. Now, in this sort of loosey-goosey world, you sometimes actually have to know what actually did happen. Python's got some type checking functions, such as isInstance, which will return true or false if the thing in the A is the matching data type. And that matches pretty well with the FEEL function is, which FEEL also has for checking data types, because FEEL's a loosely typed language like Python. There are some other similarities that make this look possible. The data types are almost identical. Even where there's a mismatch, such as range, Python doesn't have range, But it has a thing called tuple, and a 4-element tuple of character, expression, character is a good representation of a range, especially if the two characters at the beginning and the end are opening and closing brackets. Boolean should have been simple, but FEEL decided that Booleans had to have 3 values. There's a workaround. Years and months durations are a pain because, sorry, 1 month's duration isn't a constant. It's more of a concept. It's context dependent. It changes from month to month. So you have to kind of wrap that in its own data type to ring fence it, to protect yourself, so you can use isInstance int. But even when you have to do some extra work, I mean, an int's good because you can divide by 12, you get the years component, modulo 12, you get the months component. That's looking good. The other place that to look to see how much work is going to be involved and whether it's a good fit or not is the functions. Almost all the functions are already written in Python, so an implementer wouldn't have to write any of those functions. And you can wrap them in that try except thing to protect yourself from people who try to take the square root of -1. So there are more things I could have found and could have documented. I could have completed the academic proof, but it was looking kind of good. And I felt it might be possible. And I got itchy fingers and I wanted to cut code, and I did. So I didn't quite finish the academic proof. Never mind. There's always the empirical test. You can implement Python in, implement DMN in a couple of languages and then compare the outcomes. Unfortunately, I'm a one-man band and this isn't my day job. I only do this nights and weekends when inspiration takes me. So I didn't kind of get round to doing that either. So at this point, I'm kind of a bit embarrassed at asking the question because I can't really answer it. I can't tell you that it is. But what I can tell you is what I did. And maybe at the end of that, you might be able to come to your own conclusions. So 5 years ago, I was an architect at the Australian National Cervical Cancer Registry. This is a large government, federal government project to ensure that every Australian woman has a free cervical cancer screening test every 6 months, 12 months, 2 years, or 5 years, depending upon their personal risk factors. Their personal risk factors are not easy to calculate. There's about 20 variables from 3 different data sources. There's 56 levels of risk factor classification. It's quite a complicated bit. And I was the architect. I was responsible for architecting the solution for this critical part of the project, and I did. Now, I never said I was a good architect. I'd never seen a rules engine. I kind of guessed that those sorts of things existed, or you might be able to buy them. But I knew they had to have one, so I put it in the architecture. Then the rules arrived from the Federal Department of Health. They were all in Excel, but in every worksheet, in every cell, there was about 3 sentences to an entire paragraph. This was more like a brain dump than a set of business rules. So I decided to try and assist the developers by trying to restate these business rules in a somewhat more precise way, in a somewhat more understandable way for programmers. So I did. I used DMN because I knew about DMN, and I believe it to be the best documentation tool that I could find for this exact type of scenario. However, it turned out I didn't just help the developers, I actually did their job for them. Unbeknownst to me, these guys had a rules engine. buried away, that was doing some business, billing rules thing. They just repurposed it, reconfigured it with my spreadsheet, and that's job done. Now, I was extremely impressed because I didn't even know things like that existed. Things with that much functionality and that clarity. And I really wanted one of these. I wanted my own little rules engine that I could play with and configure it willy-nilly. But there was a problem. My employer, Telstra Health, was a Java and .NET shop. I don't like either of those languages, far too verbose. I like Python because I can get stuff done quickly, it's rapidly. And I really like the fact that there's a repository called PyPy that has everything I could possibly ever want. Everything that you ever need to write a Python program is up there, except DMN. Not even anything vaguely simple. So at that stage, I asked the dumbest question of my life. How hard can it be? Now, I knew what I wanted. There are two parts to DMN, visualization and execution. For visualization, Excel's okay. I can write my rules, I can share them with people via email, they can open them, they can read them, everybody's got Excel. They even started making suggestions by inserting rules, inserting rows and columns and writing rules. And that's fine, I don't mind that, because the people I'm sharing my rules with are people who are working at the coalface. And in my experience, the people working at the coalface know more about the business than the managers or even the BAs. So I'm happy to have suggestions from them. The only thing is that those people just don't have the tools to express their knowledge. DMN is one of those tools. So my attitude is just give them all DMN. Free DMN for everyone. It'd be a good thing. Anyway, now that visualizations was resolved, because I can do that quickly and easily in a Python module, the big problem was FEEL. There is no FEEL in Python, and that's going to be an issue. However, I studied computer science as an undergraduate in the early 70s. And in those days, they taught you how to write a compiler because there weren't very many of them around. I learned to use Lex and Yak. There's a Lex and Yak module in Python. So this was my opportunity to go back and relive my youth, go back to being the hippie with long hair and tie-dyed caftan and write the compiler I never got to write as a youth. This was, if you like, my midlife crisis. Anyway, I started small. I started with SFEEL. It's a very cut down version, but perfectly functional. I added lists and context and filters because I like them. And I added most of the built-in functions because I could. And very soon, with a little bit of Excel parsing, I had my own little rules engine. And I was using it at a HL7 Fire Connectathon to prescribe medications automatically. They had some business rules. I converted them into DMN and had a working clinical decision support solution running very, very quickly. I thought, well, this worked really well for me. Maybe it'll work for others. So I bundled it all together, put it up on PyPy, so anybody can install a rules engine on their laptop or server. You can include it in your application, stand up a blank rules engine, configure it with a spreadsheet, pass it some data, and get back the decision. I thought people would like this, people would download it, use it, and I get some feedback. Nothing, crickets, silence. Anyway, I was happy, or I was for a while, until I was using it in my day job in a hospital. I was grouping discharge records, 350,000 records at a time, giant batch job. There was a specification for how to group the data. It looked like that. That's a small section. There's about 9 of those, and that's the smallest one. But if you run your finger along any of that, it's tree structured. If you run your finger along any of those pathways in that tree, what you soon realize is you're actually running your finger across a rule in a decision table. Converting that to DMN is a simple linguistic operation. It's a straight translation. So I translated it into DMN, did this 9 times over, stitched them all together into a set of, into a very big solution, and it was lovely. But the code I wrote as the end user to do this was ugly. I was sorry. I was pulling stuff from the data warehouse into a CSV file, bound to be ugly. There had to be a better way of doing this. This was horrible. And there was. Power Query in Excel gives me the data, and it's got the right data types in Excel. Pandas is a data science module that slurps up the entire 350,000 rows in one big gulp. All I needed was some Panda support. Well, that's easy. Pass the data, just enhance the rules engine to accept a data frame. Get back a data frame with the same data plus some extra columns being the outputs of the rules engine. And you populate those by passing each row of the data frame through the rules engine. And then just use pandas to spit out a new data frame in a lovely looking Excel workbook. My horribly large complex group here turns out to be 7 lines of code. Now I was doing this because the official grouper had already been written by the database administrator in SQL in about 8,000 lines of code. And there was a bug in there somewhere. So we were trying to find it by passing huge data sets through both solutions, looking for differences, knowing full well that when we found a difference, I was right and he was wrong, because I was just using the specification, whereas as the database administrator had to actually interpret this, the specification and then code his personal interpretation in SQL. Lots of room for errors in there. Anyway, new release, lots of Python users. I'll get lots of feedback. Life will be good. Lots of feedback. No, nothing. Not crickets. More crickets, more silence. Okay. Next, Bert's DMN 1.3. I'm a health informatician. I belong to HL7. I have no idea what these CQL guys are on about. But they're suggesting I should write a whole heap of new functions in SFEEL. All right, I can do that. I now have SFEEL++. This is SFEEL on steroids. It's about 95% of a full-blown FEEL implementation. The next Bert was not so much inspiration, but desperation. I'd assumed because I had no feedback that no one was using this thing. I went and looked at the stats and found that it's being downloaded 4,000 times a month. I suddenly imagined tens of thousands of people using this thing and believing it was good and flawless. And I kind of panicked. I had unit tests, I had regression tests, but I couldn't put my hand on my heart and say it was flawless. I reached out to the DMN community and found out about the conformance tests, and this was my savior. This was going to save things. I'll run all those tests through my rules engine, and at least I'll know where I stand. All right. Just a bit of facts. Turns out that PyPy is a very large global infrastructure with hundreds of mirror servers. And every time I tweaked the rules or fixed something, all the mirror servers did a download. So what I was looking at was not users at all. There was probably about half a dozen users. I just didn't know what I was looking at when I was looking at statistics. I should have known better, But never mind. The fact of the matter is I panicked. And I grabbed the conformance tests, and they were all in XML. Now, I can do XML. I've even looked at the DMN schema in the early days, decided it was a bit of a dog's breakfast of a schema, and there was little or no documentation, and vowed and declared that I would avoid it like the plague. But fear makes people do strange things, such as throw away perfectly good rational decisions and implement XML support. Did that, got some stats, 88%. I'm happy with that. This is beginner's DMN. This is Introduction to DMN 101, right? DMN for everyone, all right? So the last 12% is the high-end user stuff, the power users. Those people should be buying a professional product. They should be purchasing professional support. So what can't this thing do? But that's really the more interesting question. What are the deficiencies? Well, can't do defaults. Turns out that I can't find that little underscore in the discount column because I can get back the text. I can't get back text attributes of individual characters in a text string in Python when reading Excel. Not a problem. Stick the defaults at the bottom. There's a workaround. And in fact, defaults only apply when you get to the fall off the bottom of the table anyway. So this idea of falling off the bottom of the table into the great abyss of the undefined unknown, and then thinking, oh, wonder if there was something at the top in the heading that I missed. That's really bad human engineering. So I don't mind putting them at the bottom. It's actually better human engineering. There are some certain things that I have not implemented. I don't intend to implement. Mainly if statements, for loops, and user-defined functions. For a couple of multiple reasons, they look hard. And I'm not going to do things if I don't have to, because you don't have to do these things in PYSFEEL. They're already, those capabilities already exist in DMN. A decision table is a very large if structure. You don't need another if structure buried inside an if structure of a different syntax. A decision table can call a decision table. Now, that's exactly the same thing as calling a function, because a decision table has inputs, it has outputs, it has logic in it. So the same functionality exists in DMN by a decision table calling a decision table as a user-defined function. And you can make a table loop if you want to. So, but on top of that, there's some philosophical reasons I'm not happy to try and do this. Firstly, PYSFEEL is an expression language. Logical expressions for inputs, computational expressions for outputs, and these things are none of those. These are bits of computer science 101 program structural language. Now, you don't write programs in PYSFEEL. There's no assignment operator, so you can't. So they don't look like they belong there. But there's another reason. I like DMN, love DMN, because people at the coalface can write the rules. We can leapfrog over the programmers and the business will get the application that does what they want. The last thing I want is programmers coming in and scribbling all over my rules in computer science hieroglyphics jargon and sorry, I've got a bit of a throat problem. And turning my lovely rules into basically secret squirrel business that only another programmer can read and understand. PYSFEEL is friendly enough, right? Turning my rules into secret squirrel business is not particularly friendly. So, and as I said, you don't need them. And let me just show you. This is the future value based on a compound interest, right? It's implemented in pure DMN, right? There is no secret squirrel source here. Execute is how in pyDMNrules you get a decision table to execute a decision table. This decision table, compute interest, executes itself. It does it once for every year until it's run out of years, and then it returns the value. So I don't need, I don't see that any of the deficiencies that cause the conformance tests to figures to be significant drawbacks for beginners just starting out using DMN. Okay, so what can you do with this thing? Well, this is an application written in Python. It uses pyDMNrules. It stands up a website where you can upload workbooks or XML spreadsheets, and it builds a rules engine for every one you upload. As you can see, I've got 3 of them built there. One of them is that grouper we were talking about. So that you can actually inspect your rules engine. So the bit on the right is the components, the building blocks, if you like, of the rules engine. The bit on the left is just a user input form where you can stick in some data, click on the make a decision button, you'll get back all the outputs and hence the decision. You'll also get which decision table was used and which rule in that decision table was used to generate that output. The components of your rules are actually pulled directly out of the running rules engine. Your file has been uploaded and discarded. There's hooks in pyDMNrules that lets you pull out the guts and expose it. So a rules engine has to have a glossary. If you don't provide one, it'll work it out from the inputs and outputs. But it's probably good to provide one. It's good to document stuff. It's good to be explicit about stuff, because then people who follow on from you are kind of got a start to know what's going on. The decision table is the overarching decision. It's where to start and what to do, what decision tables to run in what order. As you can see, there are a lot of decision tables to build this total solution. Now, again, you don't have to provide a decision table. pyDMNrules can work it out by doing a dependency graph, but it is much, much better if you do, because you can be quite explicit and document to people what is going to happen, and you get some extra functionality. The decisions and the order in which they are going to be run is that middle column called decisions. However, what's before that are inputs, and those inputs are tested to work out whether that particular decision table is going to be run or not. Now I've got a data-driven decision where the components of the decision are controlled by the data, right? And if you look at it, this is how I stitch those 9 things together, because 2 of those inputs make mutually exclusive things. You're either an inpatient or an outpatient, not both. You either got palliative care or you got rehabilitation, not both. So 9 rules, only 1 will ever get run. They all compute the same thing. It's ANSTAT. But they do it with different mechanisms, different rules. They use different parts of the glossary. All right, so I can show you a table. That is the one I showed you before. It's kind of looks a bit the same, right? But all the feel has been blown out to its fully expanded form. So this is literally the string that is going to be passed the feel interpreter, right? Yes, you get a little table. You can test this one small subsection of your decision if you want. If you think one of your decision tables is causing you a problem, well, you can test it here and to see how it's behaving. Now, there are also open API specifications floating around here, because when I build a rules engine, I stand up at the same time APIs for each rules engine, so that you can actually grab some JSON structure, post it to a URL, and get back a JSON structure being the decision. So this thing, this Decision Central, I can stand up, there's a version of it that runs in Azure. So, and it runs as program, as a platform. So no server, no hardware, purely running in memory. I can upload workbooks, have any number of rules engines running in the cloud, just post JSON to them and get JSON back. And I can do that in any language. So I've kind of lost interest in whether or not Python's a good fit for DMN, because I've moved up the food chain from programming to data. So I kind of need to end with a bit of an apology, because I've kind of wasted your time by asking a question that I cannot answer, I will never be able to answer, and I've kind of lost interest in answering because I've moved beyond programming to data. But perhaps you now have an idea of just how Python made it possible for a health informatician in his spare time to develop this much DMN infrastructure. Thank you.
Thanks, Russell. That definitely gives a different view, the Python aspect of things and implementing DMN with Python. I think there is a lot of people, especially from a data science background, who are writing Python. It's an easy language to kind of pick up and run with. Jan has a question over on Slack. He said that it's an interesting discussion about a decision table to decide which decision table to use. And he said, you know, it's late for him. He's in Europe, but it's like maybe something we could sort of bring out next year. Is that idea of a decision table to figure out your decision table?
Okay, so I have a slight need to recognize I have a horrible suspicion that that's one of the concepts I pinched from open rules. So you better check. That might not be an original thought.
Nobody has original thoughts. Come on, we all borrow this stuff from everybody else.
Yeah, I mean, it's quite obvious where my first exposure to this stuff was, right? It just I ended up writing a Tomcat API interface. I didn't like that, so I decided to have another go, different way.
Well, and I think that, you know, you came to what a lot of people come to who don't necessarily know about decision engines, is that it's like there has to be a better way to do this. Somebody has to have solved this problem before and sort of found your way around to it eventually.
Yeah, and I also come to it from a slightly different point of view, because a lot of the discussions I've seen and listened to have been, we've got DMN inside a workflow, right?
Mm-hmm.
I want to take it out of that context, think outside the box. There are thousands of places where I've got batch processes and other places where it's just a lot better to use DMN than what people are currently using. So I'm trying to get it out there in places outside of workflows where it could actually deliver real value to business.
Well, and I think you're a little bit preaching to the converted here is definitely the people here, with the exception of some, you know, like me, which I have a process background, and maybe Denis and a few others who have, you know, have come from the process side and look at more about how process and decisions integrate together. I would think a lot of people who are attending here are really about the decisions and not so much about process. It's just like how they can live on their own and do many other things, not just in the context of a process.
Yeah.
Okay, well, that's good. I'm not seeing any other questions right now. I think we can probably break off. We are early, but that's okay. Russell, I think we're all going to have cocktails. It's probably a little early for you for that.
Thank you, Russell.
Coffee, you. I think. Okay.
Yes.
Thanks, everyone.
You can have another coffee. Okay. Thanks, Russell.